Okay, guys, so just moving on a little bit farther into the notes here. This says, using the z-score table and our answer to the first part of the question, find the area under the curve to the right. So again, that's going to be this green area down here. And if you remember, the default is that the table gives you the area to the left. So we already figured out that this purple area right there is 0.0228. And we know that the entire thing, the entire area should be 1. Okay, that might be new for some of us, but that entire area should be 1. So this little thing over here, this purple plus green, should equal 1. So if I subtract off the purple, that will give me the green, giving me 0.977. So a little bit more shading work to come is here. So we've got the mean at 2, perfectly in the center there. And notice I marked it as z equals 0, just as a helpful reminder there. And so when the standard deviation is given as 2, if the mean is also 2, that means one standard deviation away is going to hit at 4. Okay, at 4, and then one standard deviation to the left is also going to be at 0. So it asks me in the next question to shade the area that it represents. And so similar situation here. If we've got if we went one standard deviation to the right and we shaded everything to the left. Okay, so I kind of want to do something similar there. If I erase this stuff down here, it might be a little bit cluttered right now. When it's the standard normal curve, okay, my mean is 0. And this would be one standard deviation to the right. Okay, one standard deviation to the right. And then I would shade everything to the left. And that is a similar representation when we've got that standard normal curve. So again, hopefully you're seeing the relationship there. Common mistake is that people just want to go by the one tick marks at a time. They might think that that purple line is one standard deviation, but it was given that the standard deviation was 2 in that specific scenario. A little bit more shading here now, except it's not as clear what to do. So we've got the mean at -3. So that perfect center is at -3. And then the standard deviation is 2. So again, we're going to hop 2 to the right, and that's going to represent one standard deviation to the right. Okay, so that's where my shaded region starts, is one standard deviation away. But 2 standard deviations away would get me all the way to that purple line. So if you notice, it's not necessarily the full 2 standard deviations. So this purple would be 2 full standard deviations, because you've got 1, 2 to give you one standard deviation, 1, 2 to give you another standard deviation. So it's kind of in the middle between where the end of the first standard deviation ends and then the middle of the second standard deviation. Hopefully that scenario is making a little bit of sense there. So as we look at our picture down here, we've got that mean at 0. We've got 1, if I use the similar markings here, we've got 1 full standard deviation to the right. Again, it's sigma. This would be 1 standard deviation total. Everything between the red. And notice the shading is after that. So a common mistake is that people want to call this 2 standard deviations right here, and they just want to shade everything that way. Okay, they want to shade all the way to the end. But notice my little blue area does not go all the way to the end. It doesn't even go all the way to the end of the second standard deviation. It actually cuts off perfectly in the middle of that second standard deviation. So it would actually be this sliver right there. Again, not all the way to the purple, but halfway between the end of the red and the end of the purple.